Hey there, this is Al, and welcome to tutorial, C++ tutorial number, what number is it? 135, going to be a new topic, and I've already made an attempt at this one. And I had a plan and an idea of what to do, and it just didn't work out, so I switched to something else. There is one thing, though, I'll mention before continuing. I made some modifications to my sound settings, and hopefully the clarity should be a little bit better on this one, I hope. I tested it here, and it seems like as long as I speak towards the mic and at just about the right level, everything comes out. Nothing gets muffled away. So if things do get muffled away, that's my fault. You can just blame me. The other thing is, in reviewing the last one, if you did see the last one, I told you that this particular member function of tsreg has a hidden or default Boolean argument. And I added an annotation to the last video explaining that my explanation about what that return value stood for was incorrect. And then I looked at the code, and not only was my explanation that was incorrect, not only was it true that my previous explanation was incorrect, but the subsequent explanation was also incorrect. That Boolean value, it turns out I added quickly when I was putting this back together, because this thing was using an older version of this reg class that took two arguments, and I sort of tried to map this function onto that function so that it would have about nearly the same behavior. Since then, I've decided to completely just drop that Boolean. Okay, so now there's just one argument, in-out argument. The function returns true if the operation succeeded. That's all. Okay. No errors occurred. It returns false if an error occurred. So if this function returns non-zero, you're okay. If it returns 0, then you can call getLastError to retrieve more information about what the problem was that occurred. The Windows getLastError function. Alright, the next thing I found out was mostly due to the help of one of my subscribers. I don't think he wants his name made public, but you've probably seen his name in my inbox. Well, not his name, but his handle or whatever. First he pointed me to a Microsoft website, which explained a little bit about sequence points and C++ and how the two are related. What is in C++? Is there such a thing as a sequence point? Is it defined, and so on and so forth? Well, that didn't tell me very much, but I know that C turns out. Well, it told me something. It told me about how Microsoft implements sequence points for user-defined operations. Operators, for instance, like this here. This could be the name of a function. In C++, that can be the name of a function. In C, it's not. It has a specific meaning, and there are specific rules as to what happens before and after. Something like that. And it turns out that the double AND operator in C, not C++, in C, introduces a sequence point. Therefore, it follows that this line is correct, C, and if the compiler is ANSI compliant, which the Microsoft version 8 compiler purports to be, then this is correct syntax, and there's no need to go any further looking for answers. It's perfectly fine for you to do this in this order. By the time however, the compiler does its thing, by this line, if you consider the whole program in terms of lines, numbers of, you can, if you want to, you could take everything where you can possibly make a break and call that a new line. And then there's nothing wrong with doing that. See what I'm saying? Okay, so I'll add a couple more. Okay. Well, I might as well include it. Now I'm trying to include everything. Okay. 1, 2, 3, 4, etc., etc., etc. By this point, everything above it has completed all of its business, and all side effects have been worked out, and so therefore it's okay to go ahead and use this value. All right. So that answers that question. Now, how do I know that that's true? A mixture of things. First off, it doesn't have to be true, but it happens to be true in this case because of the ANSI compliance that Microsoft has insisted upon itself to adhere to with this compiler. In fact, VC8, Microsoft Visual Studio 2005, is the first version where the first ANSI C compliant compiler that Microsoft ever produced, and also the first one with ANSI C that supports and adheres to the ANSI C++ standard. There is such a thing, with an option to not conform if you don't want. So you can turn that off. Like for what they call the Microsoft extensions are configurable. You can turn them off or turn them on as you choose. I happen to have them on, and I probably shouldn't. But it doesn't matter for me because I write these programs for myself. Yes, so yeah, how do I know? I know because in my history here, first I know from logic, I guess, or just word of mouth or whatever, that C++ is a superset of C. Okay, so that means that whatever you could say about C, you can say about C++. C++ implements C. Okay, and more, but contained within the C++ language as a subset is the C language, and it's perfectly fine for you to write your code in straight C and put .c extensions on your files, and the C++ compiler will deal with it. And within the language C++ itself, any statements that are not special statements having only to do with C++ will follow whatever C standard you've chosen this compiler to follow. Alright, now that being the case, now this is the page that friend showed me. It talks about sequence points in Microsoft C++. No. Now the language itself doesn't specify any standard sequence point. So there's a reason why that's left open, which I'll get to. And the Microsoft version of C++ uses the sequence points as defined in the ANSI C standard for expressions involving C operators, okay, and not involving overloaded operators. So an expression involving overloaded operators, overloaded, remember from 3 lessons ago or whatever it was, means same word, different meaning, right? Overloaded. Overload the name. So like this. Here's the name. If you overload this name and give it a different meaning, that meaning that you give it does not necessarily have to conform to anything to do with this standard. Okay, now that's pretty much the reason why you can't specify a standard, because the user of the language is allowed to define custom versions of operators. And most of these sequence point definitions have to do with operators. All right. Now, and there's also something called ANSI C++. Which this compiler purports to be able to be compliant with if you so select it. However, as to their own decisions, okay, now let me just make sure I get this right. When operators are overloaded, okay, the semantics change from operator sequencing to, right, of course. So operators become functions, okay, so therefore now we're talking about function sequencing, and these are the sequence points defined just arbitrarily by Microsoft for overloaded operators. left operand of logical and operator is completely evaluated and all side effects completed before continuing. Okay, so suppose you define a double AND operator that has a left-hand side and a right-hand side, right? So you have object A and object B. Object A on the left, so left-hand object, will have gone through the entire process required in order to evaluate and proceed with the execution of this function, having set all of its side effects having been settled before proceeding on with the execution of the function. All right. So, and you can say for sure that the left-hand side will have been evaluated, but not necessarily the right-hand side, and that's similar to ANSI, right? For instance, true and false. Sorry, A and B. If suppose A turns out to be false, then there's no need to evaluate B. The whole thing's false. Or operator, left-hand side, same thing for that. So these two are identical in terms of the left-hand side always getting evaluated and the right-hand side not necessarily getting evaluated because, again, or. If you have A or B and A is true, then there's no need to evaluate B. The whole expression is true. Left operand of comma operator. I've never understood the comma operator, so I'm not going to pretend I do. And a bunch of other things. Now, going back to the history. Now remember, like I said, C++ is a superset of C. So that means that C expressions, if the compiler is ANSI compliant, as this one is, will follow C specification on C expressions. And then I looked at that happened upon this page, which is a question answer type page, and that's not the one that I'm thinking of. Try and find the first one. Right, it's certainly after that. And left. No, before that. Maybe not. It's on the same page, just not that particular one. Maybe the, or, oh yeah, here. Okay, now this is referring to something that I just ran into this page. And it's referring to something that would have come before this page. Some examples. The question is, how can I understand complex expressions like the ones in this section? Well, we haven't seen the full section. However, the second part of the question contains the thing that we're after. What is a sequence point in C, not C++? Because remember, This is not an overloaded operator. This is not an overloaded operator. So this is a C expression. And that's how come I know this is a sequence point, as you'll see. Or introduces a sequence point. First, I tell you what a sequence point is. It's just like I said before. That a point, they say in time, but I would say within the C script. You know, when you can type the next line that you type, you can be sure of a particular thing. When the dust is settled and everything's been figured out with respect to something. And now that those some things are listed here, well, where you're going to find a sequence point in C. So A, or 1, at the end of the evaluation of something called a full expression. Now we get a little verb. A full expression is an expression. First we've got to know what expression is to know what a full expression is, but let's pretend we know what that is for now, and we'll check later. Is an expression statement or any other expression which is not a sub-expression within a larger expression. All right. If that's true, all we got to know is what an expression is, and we can understand what that sentence means. The complete expression that forms an expression statement, or one of the controlling expressions of one of these constructs defined by these types of statements, where the expression in an initializer. Okay, now an initializer is I think they're referring to this is C, remember, so they're not talking about the colon or anything constructor. An initializer or return statement. Okay, so an initializer, I guess, would be when you declare a variable on the stack, or a local variable, and that might be an expression in itself, like int I equals food, right? So now the expression in the initializer is a complete expression the complete expression that forms an expression statement or these statement or this type of statement and not part of a larger. Okay. So let me just try and put it into let me try to put it into something understandable. An expression in C. There's an expression in C that is that I know that that's true. It turns out I happen to know that. Now let's see how that compares with this. forms an expression statement. That's just an expression statement. Or a controlling expression of an if, switch, blah, blah, blah. So we've done case A. Take too long on this again. B. Oh, here. So this here is a full expression. That's a full expression because it completely occupies the control section of a control statement. Okay, of a control expression. That is, everything between these round brackets put together is, according to this definition, full expression. Okay, easy enough. See? Now that's also true for switch, while, for, and do while. The other types of conditionals. Or the expression in an initializer. This is a two-parter. Actually, let me put more things. Okay. This is a complete expression according to that definition. Or a return statement. This here is a complete expression. All side effects and evaluations and things will have been completed by the time this line is done. It's by the end of the semicolon. Okay? That's all. That's all. And that's all there is to it. Now, I could go on more and explain. Oh, sorry. Did I do everything? No. That was understanding what a full expression is. At the end of a full expression is a sequence point. Double or double and the question colon construct and comma operator and semicolon. I don't know if you mean this is semicolon, but whatever. Therein lies a sequence point. So if you see one of these, that indicates a sequence point has been hit, and everything following this double and may take advantage of whatever the property of a sequence point is at that time. Similarly for these two. And lastly, at a function call, after evaluation of all the arguments and just for the call. So now that's an important one. So if you had foo and so you're passing it an int, something like this. So here's a function call. In here we've got an assignment. They call another function which has a side effect of filling this in, and then assigns this I and everything and all that. All of this stuff will have completed doing its thing, and everything will have been evaluated before foo gets entered. Just before the actual call. So if there's a if following all that, there's a statement like this. That's at this point at 100 here in the code. There's a sequence point. The sequence point exists the line above that call. Okay, now there's some sort of, these are these naggly little questions that they tend to ask on your job interviews. Why is this not correct, or why is this undefined, and so on and so forth. And that's explained here, and this is a difficult one to explain. And let me see my time. Okay, maybe this will all the rest of the video will just consist of me explaining this sentence. The standard states the following. Between the previous and next sequence point in a program, we'll assume that. And I get that. We got here we got some program. Suppose there's a sequence point here. So we have some code, and we might have some object. Now this is C, so the only kinds of objects you have are like a simple struct. Like a TN, they have a struct called TN. Okay, let's take an example. A struct just has simple data types in it. Now there might be some code here. Now, some more code. And another sequence point here. Now this sequence point A, sequence point B. Between the previous and next sequence point and object, and here's the previous and here's the next, and let's suppose that the object we're referring to, it could be any object, any given object. Oh, I have to do this thing. TN is a type of struct. I don't know if I can F11 on it. See? It's got a bunch of values. So here's my time struct. So the question is, the statement that is about to be read concerns the object, my time struct, but also every object. Alright, an object shall have its stored value. So if an object stores values, which this one does, usually do, why would you have an object if it didn't store anything? An object shall have its stored, by the way, it doesn't have to be a struct, it could be an int. And so an object, no matter how complicated or no matter how simple, shall have its stored value or values modified at most once by the evaluation of an expression. Now remember that an expression, a full expression, is a thing that exists between two sequence points. Right? Well, the end of the full expression is a sequence point. Okay, so even if there couldn't be more than one full expression between two sequence points, because at the end of every full expression is a sequence point. So if there is one full expression, at most, it might be 0, between two sequence points. So now let's change this to say full expression. By definition, or nothing. That's all that you can have between two sequence points. Either a full expression or nothing at all. If it's not a full expression, then you won't. No, I'm wrong. Okay. At most. Partial. A sub-expression. Sub-expression is like this double AND thing. The left-hand side, you recall, was terminated by a sequence point, but that left-hand side was part of a full expression, which was the thing in the conditional if, right? So it doesn't have to be a full. Okay, between the previous and next sequence point, an object shall have its stored value modified at most once in the evaluation of an expression, be it full or not. Okay, so it will not modify. It cannot, according to the specification. You could do it, right? But the spec says no. So if you did modify a value to more than once between two sequence points, then that is not according to the standard, and the behavior would be what we call undefined, therefore completely meaningless. Okay, so that's the first part. Number of mod 2. So that's all that's saying. And so on. At most one modification to these values from here, between here and here. Furthermore, the prior value, meaning the value that these things had before A shall be accessed only to determine the value to be stored. The prior value shall be accessed only to determine the value to be stored. Okay. Alright. So what that says is, so I don't know how to list this properly, but again, Roman numeral, capital Roman. So that's what I says. I says, I suppose here, previous, prior, so immediately following that sequence point, you could, if you wanted to, save off the value of k prior to alright. That might be one way you could do it, right? You can just examine those values during the execution of this code. You don't have to save them all, because I mean, you're writing the code, and you can see whether or not you're modifying. So you might know at a certain point that you haven't yet modified this thing, so you call that the prior value. The prior value for any of those given objects shall be accessed only to determine the value to be stored. Okay. So now let's think about what that means. So, value of can only be used to determine the new value. You are not allowed to use this value, for instance, to determine what the new value of this object is. No. Yes, that's right. Can only be used for this purpose. Can be accessed only in determination of the new value stored. So therefore, whatever this value is at this point, it shall have no effect on this value. It can't. It's not allowed. The spec says you're not allowed to do that. Okay? I can use this value to try to figure out what I should do to update k, right? But I can't use this. Similarly, I can't use k in any way to determine what to put in here. So basically, the prior values are only allowed to be used in reference to the same object. Okay? Now, that's a little bit tricky to understand. So now I'm going to just try and look at one of these things, and then I'll stop. First sentence rules out both the examples. We haven't seen the examples, but I assume that these are they. Now the question is this legal C? And the answer is no. First of all, in this expression, I has been modified twice. Okay, and there's no time is not a sequence point, right? It's only these things and the other stuff. And again here, I is modified by assignment and by increment, and neither of these are sequence points according to this definition. Now this one refers to the second part of using one thing to determine another. Now let's suppose we look at this expression. Now A is an object of some sort, and I is an object of some sort. Both are being modified in this expression, right? But the value of I prior to entering this, to executing this expression, right, is being used in order to determine the new value for A, and that's disallowed. So that's illegal. We're not allowed to use anything we know about I. We knew about I before we got in here. In order to determine the new value of another object between the sequence points. So that's not a valid expression in C. I have a symbol. A equals B, C equals B plus E. That's certainly legal. This is certainly illegal. Now the question is, why would we want to disallow this? Well, we would want to disallow this for the same reason we would want to disallow this, right? They haven't shown a clear example where why using the prior value of any other object in the entire program between two sequence points to reference anything other than itself is not according to spec. What are they trying to prevent? And I'm not exactly sure about that. So that's it for this video, except for one final thing. And you may have guessed, yes, more smoking women. Beautiful and smoking, and open it up in just a minute. I've got the Windows key down. I'm about to hit M. Get ready. Get your cameras out. Hold on to your hat. There they are. So I can make this better by hi. There we go. Now this is I call this pastel puffers. Pastel because of the beautiful pastel-like colors. The real or not, just look wonderful on these images of possibly real people. You've got the Wicked Witch in the corner, but she's still, even though she looks kind of grimy and stuff, there's a kind of painting-like quality to that image. Like these look like if you were a painter and you draw in pastel, which are these very colorful crayons, basically. The pictures that you draw look something along these lines. Maybe not so smooth, but the same sharpness and like crisp colors. What's the word? Sharp and crisp color covering is pastel. I don't know what the definition of pastel is. I know that they used to say this is a pastel. There's a noun. It's like a crayon. It's for drawing basically colored pictures. And all of these could be thought of as drawings. In fact, I would say that the chances of these actually being real people are probably are not very high these days. The ability to reproduce and imagine human forms or any kind of form and then realize it by computer graphics is it's always at the highest point it's ever going to be at. Next year it'll be higher, but it's at a very high point now, and it's just beginning to become the case where you can't tell anymore if it's real or it's not. The only way you can tell, for me, when I get suspicious when I see something that's sort of too good to be true. On the other hand, if you recall, the last smoker that was an anime for sure, I didn't think it could possibly have been. But actually, there's something that gives it away. That gives away the possibility that it might be animated, like I just said. Not a real person, not a drawing of a person, not a photograph. Just some based on someone's imagination. And that, I think, what they've done is, like I said before, made it black and white to give it more realism. Right? It's black and white. You know, the first thing you're thinking is it's anime. But secondly, look at the background. There's nothing in the background. Okay. Now, even the worst camera in the world, right, is going to pick up something in the background, right? And it looks like this could be a road, or those might be buildings or something, but there's no detail at all. And this here, see, this looks like what is it? A cloud? These forms are actually easy to make with a computer, and it gives the illusion of that it's just a close focus shot, but it's overly done. You should see, if you don't see any recognizable image in the background, I think that is a clue that the thing might not be real. The image might not correspond to a real person. The image is real, I think. It's something, it has a reality. It's not a physical thing that you can pick up. It's information. It's certainly real. I'm talking about it. And that's real enough for me. Now I'm getting too philosophical, so I better hit stop. See you next time.